Okay, so on section 7.5, which is the last section in this chapter, and if you'll recall, all of you that were with me the whole time, that I asked you to look in the exercises for 7.3 and 7.4, and we didn't find any equal signs in there. That's all you find in this section. So somehow or another, you need to distinguish what we've been doing from what we're going to do, because they're kind of similar, and that makes it want to tie and gel together in your mind, so that when you see things from section 3 and 4 and 5 together on a single test, they're so gelled together in here that you can't separate them. So somehow or another in your mind, you need to understand that what we're doing today, trying to accomplish, is way, way different than what we did before, though we will handle them in a similar way. So that's the reason why it's always difficult for people. We're going to actually, when we're done today, we're going to actually have at the end of our problems, x equals. And it'll either be one or two numbers, depending on the situation. Okay? We haven't done that before. All of your answers to this point have been some simplification of a complex fraction, not a complex fraction, of a rational number of some kind, so that you've got x's, things with x's in it over things with x's in it. And that was the final product, and you put that in your answer. Today, they're going to be numbers, because we have equal signs now, and so we're trying to find the x value that makes the left side equal to the right side. That's our goal today. Are you with me? All right. So let's dive right in on the very first one. We've got 3 over x plus 1 and 9 over 4x plus 5. Is that right? Did I get that right? 3 over x plus 1. 3 over x plus 1, 9 over 4x plus 5. And the big, huge, gigantic difference, which is hard to notice as a big, huge, gigantic difference, is this is not a plus or a minus, or even a times or a divide. This is an equal sign now, handled differently. When you have, and this is something I would like you to default to no matter what for the rest of your math career forever, you've probably already done it. But whenever you have one fraction, just one fraction on the left, equal to one fraction on the right, when you have that situation, you got an equal sign between, you should cross multiply. Remember what cross multiply means? You always did it with proportions in geometry. Remember when we said 3 is to 5 as 7 is to x plus 1, and it was some diagram, and it was similar triangles or whatever. Remember how you wrote proportions? Yeah. So it's one ratio equal to another ratio, or one fraction equal to another fraction. If that's the case, you should always default to cross multiply, and it shouldn't be a difficult thing for you to decide on. So cross multiply means to take this times this equals this times this. That's the way we're going to flatten the fractions out into something we can handle. Okay, so it's going to be 12x plus 15. Do you understand that move? Equals 9x plus 9. So in a situation like this, just cross multiplying immediately reduces it to something you learned in chapter 3 of Algebra 1.
Why wouldn't we just, whenever we had like fractions that are subtracted on the last one, why didn't we just add it over?
Because there was no equal sign. You were simplifying an expression. You were not solving an equation. When you just move it over, you have to have an equal sign. You got to be equal to something. Even if it's just 0, you got to have an equal sign. And that's an excellent question, because that's part of the problem people have separating what we've been doing with what we're doing. There was never an equal sign, and your only option was to deal with one side. There was no flow through. There was no gate to open. It was just an expression. It's kind of like the difference between studying, I don't know why you would ever do this, but a fragmented sentence in English as opposed to a whole sentence. These have now got verbs in them, predicates, if you will. We didn't have that before. We just had a thought, just a fragmented sentence, and was no place to go with it. Now there is. Our objective is to get at x. And so it's an excellent question. Get that done in your mind. There is no place to move things when you're simplifying expressions. You just got to deal with that expression and do it the best you can and get it as simple as possible. This, though, now we've got the gates open, we can cross multiply. And when we do and cross multiply to this, it becomes a very easy problem. This is going to be 3x equals negative 6. Do you see that move? Yeah. You should be good enough at that. You'll be able to see this move by now. Everybody see it? Yeah. So x is negative 2. Here's the problem. And I'm gonna do this with every single problem. It's not a problem in this problem. You'll see in a minute.
We need to start with the club and organization pictures this morning. So we will start with sources of strength and yearbook. So if you are a member of the sources of strength or a member of the yearbook, go to the auxiliary gym now. Thank you.
If that involves you, then I guess you're gonna have to view this at some point and pick up the missing pieces if you need it.
Thank you.
For everything today, I want you to remember that when you get down to a number, it is possible, especially with what we've been dealing with this chapter, it is possible that what you get for an answer doesn't really work. Because remember, there are three things in algebra which cause solutions to be extraneous. And that is if they cause you to divide by 0 in the original equation, if they cause you to square root a negative, or if they cause you to log a non-positive. The only one of those three situations we've got this entire chapter is the possibility of dividing by 0. When I do these problems, because I've done this for many, many years, the first thing I do when I write it down is I look at those denominators and I say, if I get a -1 or if I get a -5/4, I'm going to throw it out. I'm already anticipating what I'm going to get. I didn't get either one of those, so I will keep this solution because that does not make division by 0 in either case in the original equation. Are you with me? You have to check. Anytime the beginning equation has one of those three things in it, an even root, I shouldn't say just square root, an even root, a logarithm, or a fraction, you better be anticipating the possibility of extraneous solutions. This one's not, so we will keep it. Okay, I'm going to come back to example 2 in a few minutes. I want to keep going on this theme of solving equations. So I'll be back to example 2 in a few minutes. It's a story problem, which I'll be back to. Okay, example 3 says just solve the equation. I have 5 over x plus 7 over 4 equals -9 over x. 5 over x plus 7 over 4 equals 9 over x. Is that what I said?
It's negative.
-9 over x.
-9 over x. Is everything else correct?
Yeah.
Okay. Now, compare what we started out with here to what we've got here. These denominators are less complex. However, we don't have a fraction equal to a fraction. We have a sum of 2 fractions equal to a fraction. Now, you might think, and you could do this if you wanted to, you might think we're going to add those 2 together to get a single fraction and then cross multiply, which you could do, but I'm not going to demonstrate that. I'm going to show you a better way. Gets to it quicker. And that is when you don't have the situation, cross multiplying is not an option, then you start looking at denominators and choose the common one. And if you have to factor some things to choose it, you do that. Just like you did before. That's the reason why we say, well, we always find a common denominator. It's what you do with that common denominator that's determined by different situations. In this situation, we find the common denominator, which is
X.
4x, and we multiply every term by that. It's kind of like a distribution through the entire problem across equal sign and everything. That's why I put the whole thing in parentheses. Every term is going to get multiplied by that common denominator. And as we do it, anything with a denominator, if we chose the correct one, anything with a denominator is going to have their denominator canceled. So if I multiply this times this one, the x's cancel and I have 20. You with me? If I multiply this times this one, which is the next thing, the 4's cancel and I have 7x. This sign sticks. And over here is my equal sign. If I multiply this times this side over here, the x's cancel and I have -36. Again, with that little trick leading off here, we end up with something that you could have done in Algebra 1. I have 7x equals -56. So x equals -8. Did any of you anticipate what we might get that would cause a problem? What would cause a problem if we had gotten what?
0.
X equals 0, which we did not. So we will keep this. 0 would have been the only solution that would have caused us to reject it. Y'all see that? So in that little trick right there, choosing a common denominator like we did yesterday and last Friday and all weekend long, we were choosing a common denominator, but what we did with it was way different. When you chose a common denominator when it wasn't an equal sign, you decided which denominator, which pieces of the common denominator each denominator was missing, and you multiplied the top and bottom. That's totally different than what we did here. We found a common denominator, yes. But what we did with it is we multiplied every term by it, eliminating the denominators in the process, leaving us a nice, flat, solvable equation.
To the auxiliary gym for pictures, CPA students, please go to the auxiliary gym.
Okay, let's try another one that's like this. That's got a little bit different little quirk to it. We have 1 minus 8 over x minus 5. 1 minus 8 over, get that written right. 1 minus 8 over x minus 5 equals what? It's the B part.
3 over x.
3 over x. Okay, again, cross multiplying is not an option because the left side's got 2 terms on it. Anytime either side has more than 1 term, cross multiplying's out. So I look at my denominators. There are 3 terms, only 2 have denominators, and of those 2, the common denominator is x and x minus 5. Don't just think it's x minus 5, because remember that's a term. It's going to take one of these and one of these. So that's what I'm going to multiply by all the way through. So I chose a common denominator, and now what I do with it is this. I'm going to multiply by x and x minus 5, canceling as I go. Are you following me? So when I go to multiply x and x minus 5 times this term, nothing cancels. Happily, it's just a 1. So this times this is x and x. Then when I go to do this one, the x minus 5 cancels, and I'm left with, now pay attention here, I'm left with negative 8 times x. You see that? Equals. And here when I multiply this times this, the x's cancel, and I'm left with 3 times x minus 5, but I'm not going to deal with that in this step. And I suggest you don't either. Just let your mind focus on what cancels and writing down what's left. Don't try to do any of the math. But then, when you see what you've got after canceling what you can, again, Algebra 1, Chapter 3 problem. It's just this is a little more involved because we got to do some distributing and combining like terms first. But none of that's hard. So on this one, I have an x squared minus 5x minus 8x equals 3x minus 15. At this point, you might recognize you got a quadratic, and it's the quadratic term is positive on the left, so I'm going to bring those guys over here as I combine. Is that okay? I have x squared, and here I have a negative 13x. Minus 3 more x's is negative 16x. Can you handle that in one move? And I got to bring that 15 over to it. It's the only constant in the problem, so it's going to be plus 15 when I bring it over equals 0. And at this point, you have 4 options. You can. The 2 algebraic options are to factor it if it will. And it will. I hope you can see that very quickly. That's going to be your quickest move, even beyond your calculator, because your calculator takes a lot of button pushing and a lot of waiting and a lot of searching, like polyroot finder, stuff like that. But these are your options. You can factor it if it will, and this will. You can quadratic formula it if it won't. Those are 2 algebraic solutions. You can polyroot find it. You can graph it and find the zeros. I'm going to factor because it's the quickest. If you can recognize it'll factor, factoring is always quickest. That's the reason why we even leave it as an option. I'm going to have 15 and 1. And they're both going to be negative so that I can get down to negative 16. So x is either 15 or 1. No problem. A 5 or a 0 would have caused me problems. I didn't get either one of those.
Why would a 5 cause you a problem?
Because 5 minus 5 is 0.
Oh, okay. Sorry. Will there be actual problems that it doesn't work for?
Absolutely. Good question. It's coming up right now. Did everybody follow all of that? This multiplying through by the common denominator, did y'all follow that?
Yeah.
And if you have any terms that don't have a denominator, nothing cancels. So you're going to have to multiply that single term with no denominator by both pieces, like we did at the beginning of this.
So if one had if it had something like x, then we could use a cross multiplier now.
You can only, if you have something like, I think I understand your question. If you have something like this, x equals 1 over 3 minus x, yes, you can. Put a 1 under there, cross multiply.
Okay.
Yeah. But it's only if you've got one thing on the left and one thing on the right. No addition or subtraction on left or right. And that's not the case we had in these 2. But it's a good question. But if you have just a single thing over here, it doesn't have a denominator, you can make a denominator 1 for anything.
Okay.
Okay? Okay. All right, so now I'm going to erase both of these, and we're going to apply that same strategy to the next one. That's example 4. I have 6 over x minus 3 equals 8x squared. Ooh, it's getting worse on the denominators now. I got more stuff in there. Still the same strategy. And minus 4x over x plus 3. Okay. This one's going to take a little more effort to choose the common denominator because as it was with yesterday, choosing a common denominator requires that we be able to see all the factors. And this one needed factoring. Did you follow that? Everybody understand why I'm doing what I'm doing? I need a common denominator, and I couldn't see it until I factored this. Well, I could, because we all know what that difference of 2 squares is. But if this is more complex, a 3-term quadratic, for example, you have to factor it to see the pieces. That's what I'm doing here, and it looks to me like the common denominator is x minus 3 and x plus 3. So that's what I'm going to multiply through by. And it is advisable to just leave this factored right here, realizing we're not going to really look at that as the factors we're interested in, it's these 2 pieces. So when I go to multiply through by that, when this first one right here, I'm going to lose the x minus 3s, which leaves me with 6 times x plus 3. Again, resist the temptation to distribute that. Don't let your mind switch gears. Just cancel what you can and write down what's left. We'll deal with this in a minute. Equals. And then when I go to multiply this one by this one, they both cancel, and I end up with 8x squared on this one. Do you agree? You following what's going on?
Yeah.
They both get lost out, and that's good. And then when I multiply this one times this one, the x plus 3s are out, and I have a negative 4x times x minus 3. Did y'all follow that?
Yeah.
And that flattened it right out, makes it a algebra 1 problem, just that quick. Would you like me to go through that again? No, I'm seeing some question marks on some people that just joined us. You want me to go through that again? Okay. You understand the choice of my common denominator after I factored this? You understand why I chose the 2 things?
Yes.
Okay. All right. So what I'm gonna do is multiply 1, 2, 3. I'm gonna multiply each of the 3 terms by this common denominator. And in the process, everything with a denominator is gonna lose something because I chose the correct common denominator.
Yeah.
So if I multiply this term right here by these 2 things up here, remember this is the numerator. It's over 1. We understand that. And so I'm going to lose an x minus 3 and an x minus 3. Here I got one on top here and one on the bottom here, and that leaves me with 6 times x plus 3 in this term.
Okay. Yeah. Okay.
Do you want me to go through the rest?
No, I got it.
Anybody else need me to follow through again? Okay. Do you understand this first move?
Mhm.
Okay. And then if I go over here to this one, because every term is going to get hit, I'm going to multiply this term by these 2 things, and they both cancel. I lose the x minus 3s and the x plus 3s, and I'm left with just 8x squared. Because they both canceled out in this term.
Okay.
You see what I'm saying? Okay, so we're left with the numerator times 1. Because they both canceled out. Both of these are gone. The whole thing right there. My hands are big enough. Okay. Then I multiply by this one. Don't forget this negative belongs to this when I go to multiply. So when I go to multiply by this one, I lose the x plus 3s. See it? And I end up with negative 4x times what remains, which is x minus 3.
Your attention are ready for the next couple of groups, FCCLA and HFLA. If you'll go to the auxiliary gym, FCCLA and HFLA, the auxiliary gym.
Please, please, please resist the urge to try to simplify this as you write it down. You will make mistakes. Do one thing, and that's cancel what you can and write down what remains, and that's all in this step. I'm not trying to make busy work for you. I'm trying to help you follow that if you don't have time to do it right, when you have time to do it over. This is how you do it right. Let your mind focus on one thing at a time. That way you don't overload your conscious memory. Okay. Then we switch gears now and we handle this like we would have in Algebra 1 by distributing and combining like terms, but I'm going to do one thing at a time. Okay.
just brought over the 6x and 2 the other side.
The reason I chose this side is because I realized that in subtracting these, I would still have a positive. I want to bring things over this way. Okay? At this point, we have a quadratic. We have 4 choices again. Factor it if it will, quadratic formula, polyroot finder, or graph it and find the zeros. Pretty sure this will factor. So I'm going to work on the factoring. You may want to jump immediately to electronics. That's up to you. Once you get to this point, you've got 4 options for solving a quadratic. I'm going to take a 2 out of everything. Yep. Factors. So that means that each one of these gets their shot at being 0. 2 will never be 0, so I can ignore it. This will be 0 if x is negative 3/2. I'm sorry, positive. If x is positive 3/2. Remember back over front opposite sign? 3 over 2, opposite of that is 3/2. This one's going to be negative 3 because negative 3 plus 3 is 0. Will either of those cause me trouble? And yes, right there. If x is negative 3, negative 3 plus 3 is 0, so I will reject this one. The only things that had a chance of causing me trouble was 3 and negative 3, both of them here. 3 and negative 3 were troubles, and I got a negative 3, so I'm going to reject that. And the only solution then is x equals 3/2. And it would be helpful to me to know that you checked it if you put that whole thing in the blank on a test. Just cross out the one that was rejected. That tells me that you checked it out. Did y'all follow that? I know that was way down on the bottom of the board. Were the rest of, we were all able to see it? This one did have an extraneous solutions. The first 3 that we didn't, but we have to check. Always have to check. If you start out with a chance to divide by 0, that's one of the 3 problems with high school algebra. Bad solutions. Okay, I got this example, and I'm going to go back to example 2. Example 5 is a different story. We're not solving equations anymore. We're trying to find the inverse of a rational function. So in example 5, slightly different. So I'm going to put a line here. We're not doing the same thing. Hopefully it'll help you separate it in your mind. In example 5, it says, consider the function 2 over x plus 3 and determine whether its inverse f is a function and then find it. F of x equals 2 over x plus 3. And it's a strange thing to ask. It says, determine whether the inverse of f is a function and then find its inverse. What if it's not a function? Can you still find its inverse? Yes, you can. It's just when you go to graph its inverse, it won't be a function. Now here's how you make that decision. Y'all remember the horizontal line test that I taught you? So graph that function in your calculator. Make sure you put x plus 3 in parentheses. Graph this function that I've written down. Make it a habit of always putting your numerator and denominator in parentheses between the divide sign. It's just a good habit. Go on a standard screen. Looks like a pretty normal rational function that's been moved a little, right? Is that what you're getting? Make sure the x plus 3 is in parentheses. You won't get this. Everybody good on that?
Good.
This is what you should be getting, something like that. If I keep the glare off of it. So, considering this, first of all, is the thing you're looking at a function? Can you imagine a series of vertical lines that only hits once? Sometimes not at all. Right there, it doesn't hit it all. That's okay. As long as it doesn't hit it more than once.
Wait.
Is
I think
Hang on,
X
that's
plus 3.
Yeah.
Oh, yeah. I don't know where I was. Maybe I was looking at that one when I looked up really fast. You're right. Let's fix it. Okay. Yeah. Still an asymptote, but it's on the left side of the origin, right? Okay. Sorry, folks. I had the wrong thing in there. This is what it should look like. Okay. All right. So this one satisfies the vertical. I actually have a graph correctly now, right? Matches yours. Okay. Satisfies the vertical line test, so it is a function. Will its inverse be a function?
Yes.
How do you know? It will be, but We can tell from this one if its inverse will be a function because this one also satisfies a horizontal line test. So it will satisfy a vertical. You know what I'm saying?
Yeah.
So since this horizontal line test is satisfied on this, we know we can answer the first question, which said, consider this function, determine whether its inverse is a function. It is. You can tell from the graph. It says, then find the inverse. Even if it had turned out to be, no, it is not a function. If the horizontal line test failed on this, you would still be tasked with finding its inverse. Here's how we go about, no matter whether it is or is not, the inverse is a function or not, we will find its inverse by switching x and y. Did you catch that little move? And then resolving for y. Now, the reason why this is in this section is because I recognize, just like Christian suggested, I actually have a fraction equal to a fraction. Which means cross multiplying is a good move. See the fraction over here? Can y'all see it?
Yeah.
That x is in a denominator over 1. I'm not going to write that. You're sophisticated enough you can see it. So I'm going to take this times this, which would give me xy plus 3x equals 1 times 2. Now remember, our objective is to solve for y. So I need to get this y term by itself by kicking this over there. So I'm going to have xy is equal to 2 minus 3x. See that move? And then divide by x. Now I'm going to show you an alternate method here, and you can do this if you want. This one actually needs one more step. The author probably on Big Ideas Math will require it, and that is to divide x into both of them separately, and that would look like this. See what I mean? Divide it into here, you still have 2 over x. Divide it into here, the x is canceling out, just minus 3. Now let me show you an alternate way to solve it from here. So I'm going to go over here, and we're going to go down again. Another way to do it is rather than, and you're still going to cross multiply, but rather than distribute it, just leave it like this. X times y plus 3 equals 2. We could leave it like that. Then get rid of the x by division. See that?
Yep.
And then subtract 3. And you end up with the same solution, but that one's a little cleaner. If you can resist the urge to distribute when you cross multiply, just leave it. This times this. Then get rid of the x by division and the 3 by subtraction. You also solve for y. It's a little cleaner. I would give you credit for this or this, but Big Ideas Math may not. So if you do it this way, you may have to divide x into both and recover what would have happened if you'd done it this way. 2 different methods, same solution, and either one of the things in the circles is acceptable. 2 different versions of the same thing. You okay on that? Okay, I'm not going to do example 6. It's a silly thing, and I don't like what they're discussing there, so because they're wrong, so I'm not going to do it with you. We're going to go back to example 2 now and see if we can apply any of this to a real life situation. And this is a real life situation. It's pretty cool, actually, this particular problem. So you read it, example 2, while I get rid of this, and we'll talk about it. Please don't look at the solution. I want you to come up with a solution on your own. Okay. Come on in. So what we're trying to do in example 2 is we're trying to melt down different versions of silver. There are different kinds of silver. And we are trying to melt them down and do a mixture appropriately enough to create sterling. That's a higher grade silver. It's got more silver in it. Okay. So let's read it together. Now that you've read it once, let's read it together and we'll see if we can figure some things out. Don't look at the solution. An alloy is formed. That means you're going to mix the metals together by melting them. Mixing 2 or more metals. Sterling silver is an alloy composed of 92.5% silver and 7.5% copper by weight. Does that make sense to you?
Yeah.
Copper weighs a little bit more than silver, but 7%, 7.5% of the weight of the metal is copper, and 92.5% of the weight in that metal is silver. You with me? By weight, okay. You have 15 ounces of 800 grade silver, which is 80/20. It's not as good as, it's not as silvery as sterling, okay? And we wish to take the 800 grade, we've got that, and we've got some pure silver over here, and we want to figure out how much pure silver to add into that and melt, so that when we cool it off, we've got sterling. We're beefing up the silver. Okay? All right? How much pure silver should you mix with the 800 grade to make sterling? Don't look at the solution. Here is how you figure percentages in case you were wondering. You should know by now. But to figure out how much we have, we take the silver, no, the amount of, let's see if I can, do you want to deal with the silver or do you want to deal with the copper?
Silver, copper, whatever one is easier.
Which one would occur to you to do? Which one would you put down if you were doing this problem without looking at this solution, not knowing how?
Silver.
Copper,
That's what we're adding.
copper is smaller numbers.
So you'd go with copper? That sounds reasonable? You want to go with the copper?
Sure.
Okay. Percentages are, if we go with the copper, is copper, the weight of the copper, or whatever you're figuring a percentage on. When I figure the percentage you get on a test, I take the number of correct answers divided by the total number of points available, right? So if I take the weight of the copper and divide by the total weight of whatever it is, I mean this, whatever I've got, if I take the weight of the copper and divide it by the total weight of the metal, that will be what percent copper I have. And for us, that is 7.5 to 100. We're forcing the percentage idea to come out here. 7.5 pieces out of 100 is copper. That's what this translates to for what we want. This is what we want. This is what we want to have. This is how we're going to get it. We got 20% copper, right?
Yeah.
How much of this? How much? Because we don't know how much of this we've got. Well, sorry, we don't know how much of this we're going to get. This is sterling here. This is copper to total. This is sterling silver here. This is.
Oh wait, we have 15 ounces.
Oh, that's what I wanted. The 15 ounces. So 20 to.
Oh, we have 15.
Wait a minute. I want copper. Ooh, this is going to be tougher. How much copper is in what I have right now? 20% of what? 15. We got 15 grams of the 800 silver, right? The cheaper silver. We got 15 grams of it. 0.2 of that is copper. Right? And that would be over, total weight would be 15.
Yeah. Oh, so wait, what did we just ask about that? 15 here. What's X?
What's X?
That's what you're trying to find out, isn't it?
I don't know. Can you tell me what X represents in the context of this problem?
Does that represent the final weight that you get from adding?
The amount of silver that you need.
It might be the final weight, but I'm sorry, what should X represent?
The amount of silver that you need to add.
Yeah, it's the question. The question says, how much pure silver should we add? That's what you let X equal. So up here, and again, gathering all my information together here, I'm gonna, so that it's a concept in your mind, I'm gonna let X equal the grams, G, well, it's equal to the pure silver that we're gonna add, measured in grams. Because this is all about weight. We're going to pile in pure silver until we get sterling grade. This is what I'm going to add it to. Am I going to add any copper?
No.
No, we're not going to add any copper. We're going to add pure silver. And so the weight is going to be 15, which is what we have now in the 800 grade silver. And to that, the total weight's gonna be 15 grams that we've got, plus what we're adding. Until this turns into this. Did you catch all that? It's two ratios put together this way. The weight of the copper to total weight. This is what we want. The weight of the copper to be 7.5 to 100, whatever that is. And I say it may be measured in grams or kilograms. It could be measured in anything. But the ratio is 7.5 to 100 copper to total. This is also copper that we have right now. We're not adding any more copper, so this stays the same amount. This will be the total weight after we add the silver. So this is copper to total also. And I want to add enough until this ratio equals this one. I want to turn this, which was this. That's what I've got right now. Copper to total. And I'm going to add weight to it in the form of pure silver until this ratio turns into this one. Does this make sense?
Yeah.
Both of them are put together the same way. Weight of copper to total weight. Total weight's being added to. So now we cross multiply. 7.5 times 15 plus x. Putting that together is the hard part of this. The cross multiplying is no big deal. And then I take 100 times 0.2, that's 20, times 15.
Would you not want to simplify the 7.5 over 100?
We could. I don't know. What would that be?
3/4.
What?
3 over 40.
3 over 40? We could turn that into a fraction that doesn't involve decimals if you want. I don't want, but you could. That'd be no problem. What's 7.5 times 15? That's the next thing we got to distribute.
112.5.
112.5
Yeah.
plus 7.5x equals what's 20 times 15? 300?
Yeah.
So we're going to take 112.5 from 300. That gives me 7.5x equals what's 300 minus 112.5? 187.5?
Yeah.
And then divide that by 7.5.
25.
Wow, that's a lot.
We need 25 grams.
Need 25 grams of pure silver to add to the 15 grams we already have to bring it up to this ratio.
That's
It's ounces, actually.
Question?
It's ounces, not grams.
Oh, it's not grams? Ooh, sorry then. The whole thing's in ounces? Sorry.
There's not over a pound.
Oh, yeah.
There's not over a pound of pure sugar.
Yep.
I mean, pure silver.
This was almost a pound of 800 grade. Almost, because we've been 16. Almost a pound of that. We have to add over a pound of pure silver to make it sterling. To bring that up to only 7.5 to 100 as opposed to 20 to 100 in this instance. Got to add quite a bit. So you may run into a couple of story problems that are built on that. You're going to have to think how percentages are figured in the problem. It's weight over weight. And try to reason it through. Make sure that you let X equal what they're asking you to find. Then that'll help straighten out your thinking a little bit. Okay, so it's about solving equations today. You're going to end up with answers. Make sure you check for extraneous solutions. There are only 13 problems to do. It's not too bad. Those of you doing it on paper, here's the assignment. This is section 7.5, and it is 7 to 13 odd, 19 to 30. Dude, it's way more than 13 questions. I don't know why I said that. And 39 to 43 odd, 47 and 49. So it's way more than 13. I gotta recount it.
No, I hope so.
I don't know what I did. Screwed something up. But it's more than that. There you go.
Yeah, I looked at it on my